Hello, my name is Raymond Knopp. I'm happy to be here virtually with you all. I'm going to talk about cloud-native deployment of OpenAirInterface and some of the new and exciting things that we're doing inside of the community. This basically concerns the usage of OpenAirInterface for cloud-native networks, meaning we're, in the context of OpenAirInterface, deploying the radio access network and core network components using modern tools such as Kubernetes or Red Hat's OpenShift. So the key objective in this has been, we've been developing this over the last 2 years, around the last 2 years with in partnership with Red Hat, was to bring the OpenAirInterface RAN and core network components into some of the cloud native tools that Red Hat is proposing. And there is actually a GitHub now called OpenAirInterface K8s, which represents the bulk of this work. And this is really a co-development with Red Hat today, which targets the OpenShift Enterprise Kubernetes solution. And anybody can actually replicate this today with the proper hardware. You know, as we were doing this work, there were many challenges. And the main challenge in terms of the amount of effort needed to put it together was to have access to a reasonably sized and high performance infrastructure where we could actually test OpenAirInterface in its cloud native version. And some of the real issues are related to the real-time or low-latency processing to make the radio access network work in this context. Other areas that were challenging are some of the user plane optimizations. For instance, using tools like DPDK for the front haul, mid haul, back haul interconnections between elements in the cloud. And finally, which I'll talk about a bit later today, is the integration with automation frameworks such as ONAP, to allow for a fully automated version of the deployment of these tools in a cloud environment. You know, one of the other outputs that came from this activity are really blueprints for the community. Everything, of course, that we're doing here is open. And this will allow people to mutualize setups and minimize the effort in deploying OpenAirInterface in a fairly complex environment. It'll also allow people to replicate experiments and from a research perspective, provide what researchers call reproducibility. It'll also allow for testing on larger scale experimental facilities. And I'll give an example of how we use this in the context of one of the 5G PPP facilities in Europe, but partners in the United States, for instance, in the Power or OpenNV framework, could also reproduce some of this. In fact, that is something that Red Hat did in the context of other OpenNV projects. And finally, also, we've now integrated this into our CI/CD methodology. So that's something actually that the community is using now when they do merge requests into the OpenAirInterface codebase. So where do we stand today in this respect? All core network and RAN components are now Docker compatible, or Podman if you're building for a Red Hat-based system. And this is now native support inside the OAI Git repositories. And the container image testing is now also part of the OpenAirInterface CI/CD, at least to a certain extent, and will be more so in the coming months. With respect to Kubernetes, today we already have the builds for Red Hat OpenShift, and they're ready and running on a few clusters. We can say now. And the integration with respect to Kubernetes is actually also going to be done in the context of our CI/CD fairly soon at this point. And both the RAN and core components, as I mentioned before, are on the OpenAirInterface K8s GitHub. With respect to ONAP, today the core network, the 4G core network, and the 4G and 5G radio access network components are ONAP ready. So we put the necessary Helm charts together so that you can deploy OpenAirInterface in an ONAP environment. And this is something that's under test with the 5G EVE infrastructure at Orange Labs in Paris. And I'll talk a little bit about that afterwards. What are our real needs? Today, we need to have more generic Kubernetes builds, and there has been some initial work in the community in this direction. We also need the new OAI 5G core network elements to be ready for Kubernetes. They are already ready for Docker, but not strictly speaking for Kubernetes today, and this is coming. And we need more community replication so that other people can test this framework in their own environments. Now, if I talk a bit about some of the interfaces, you know, when we talk about cloud native support, we're also talking about RAN and core disaggregation. So we want to be able to support, in the context of our community, numerous interfaces so that we can have full disaggregation of the RAN and core. By this, we mean some of the front-haul interfaces, and today we are integrating EC-PRE and ORAN 7.2 solutions. Mid-haul interfaces like NFAP P5, P7, the 3GPP F1 interface, 3GPP E1 interface. E1 we do not have yet. RAN controllers that make use of the E2 interface from the ORAN Alliance. Also network management, such as the NFAP P9 or the O1 interface from ORAN and others. And also monitoring interfaces and packages such as Kafka and Prometheus. We want to support, in this spirit, the Open RAN Policy Coalition through proof of concept demonstrators. So by this, we mean the use of OpenAirInterface in conjunction with other solutions to build end-to-end demonstrators. And all of this should be based on cloud-native technologies, using Whitebox radio solutions, and I can give a couple of examples in a minute, in addition to USRPs. And we should also strive for multi-slate deployments in order to test these ideas. So now if I talk a little bit about our infrastructure, which is called Open 5G Lab. Open 5G Lab is a Kubernetes cluster. Today, we have 3 or 6 terabit per second switches. Some are Tomahawk based, others are Barefoot Tofino based or P4 switches. 5 of them are used for a switching fabric, and 1 is actually used or will be used for a 5G UPF that'll be provided by a company in Canada called Colume Networks. The Kubernetes servers, if we look at the worker nodes, these are all high-end Dell Xeon Gold servers, so 36 core machines. There are 8 of them today, and that number is growing. We have simpler worker nodes for different applications that are also available on the cluster, and these are smaller, like quad-core x86 nodes. And we have 3 master nodes today that play the role of Kubernetes masters. There is one node, which is a jump host, which allows people from the community to come in, or those that we've given access to come in and deploy software on the cluster, or use some of the nodes in the Sandbox. The current interconnections we have on our cluster, we have a 1 gigabit interconnection with the Renater or GL network today, over which we have a tunnel with the Orange Labs network in Paris. It's around 500 megabits per second for control plane and moderate user plane interconnections. And we're planning a very high-speed interconnection to the locally to INRIA and the Renater network infrastructure for early next year. Today, the cloud infrastructure is really based on Red Hat OpenShift 4.4, what is deployed at EURECOM today. And we also have a bare metal sandbox, which really consists of several radio nodes and machines for unitary development and testing, and also community access to our infrastructure. This is in pictures what it looks like today. You can see on the top the switching fabric. Yeah, there are 6 switches which are in a leaf spine configuration. The 2 switches, one of them has an interconnection today to the, as I mentioned before, to Renater and to the Orange facility in Paris. And the other switch will be connected to the future EU research fabric, which will go up to around 400 gigabit per second. You can see some of the partners, those are all, not all of them, but at least the academic partners are working with us in the context of OpenAirInterface on some of these technologies. On the left-hand side, you see some of the partners that are working in the context of OpenAirInterface on these cloud-native deployments in their own facilities. So we basically have a couple of top-of-rack switches, a bunch of servers, and in here we run Red Hat OpenShift, in which we instantiate both the RAN components, so you can see the LTE and NR RAN, the EPC, and soon the 5G core as well in here. And there is also some work going on with partners at EURECOM on mobile edge compute functions inside this cluster as well. So that is our basic experimental infrastructure for cloud native deployment of OpenAirInterface. If we look at a more concrete example of where this fits into a larger infrastructure, this is the 5G EVE infrastructure, at least the component in France, which you can see is centered around a cloud which is in Paris, in Châtillon is near Paris, where they have an ONAP cluster. and a server farm. And these are interconnected to different sites in different parts of France. You can see our partners Beacom here on the left in the northwest of France, ourselves in the south. So this was the infrastructure I just described. And there's a commercial 5G infrastructure at Nokia premises in Paris as well. So basically our infrastructure here is interconnected to other infrastructures in France, and they're all centrally automated using an ONAP framework on a cluster that's maintained by Orange. So if now we look at some of the radios that we have here at EURECOM, this is an example of the installation that we have connected to our cluster on the roof of our building. There are different radios. This is one of them used based on a National Instruments USRP N310, interconnected with some power amplification coming from a Chinese company called Zichun Wireless, which is connected to an antenna. And this rooftop installation is connected over SR optics at around 300 meters to our server room, where all of the compute and switching components are located. So this is a real world deployment of OpenAirInterface around EURECOM's premises. We also have other what we can call Whitebox radio units, in particular one from an Irish company called Benetel, who is an OAI member, and another French company, AW2S. Both of these provide what we can call Whitebox radio units. So in one case, it's an eCPRI, and in the other case, it's something, at least in the user plane, which implements ORAN 7.2. And perhaps Florian will talk a little bit about that, or has talked about it already, in terms of the fronthaul. These are higher power solutions, in one case around 43 dBm, but can actually cost less than putting together a prototype like the one I described earlier with the USRPs. They're less generic and flexible than a USRP, but these are complete products, and they're ready for deployment in very specific bands. Today, both of these are deployed in our lab. One of them will be going up to the roof in a week or so. In frequency range 2, we have these radio units that are developed by our partner InterDigital. These operate from 24 to 29 gigahertz and can be interconnected with a USRP. In this picture, it's with an N300 USRP, but ultimately these will be driven by N320s for larger bandwidth. So this is let's call it an experimental radio unit, but that will allow OpenAirInterface to work in millimeter wave frequencies. So what are the takeaways here of my talk? OAI now has cloud-native solutions. So OAI can be deployed on a Kubernetes-based framework and a real-time Kubernetes-based framework in the context of the Red Hat solution. And it is also ONAP ready at this point. We do need to complete new interfaces for the RAN to allow full disaggregation in the spirit of Open RAN. And we do need industry support for integration of operation and management interfaces so that we can actually test this at scale in multi-sites. Now, the infrastructure at EURECOM is used to include this cloud-native RAN and core targets for the CI/CD. It's also used to work with partners to replicate on other clouds and propose multi-site experimentation and proof of concepts. And it's actually also potential here for transatlantic interconnection with our partners inside of Power. Thank you.